Hey everyone, welcome to the YouTube channel of NITA. Myself Mayur, a second year CSC undergrad at NIT Agartala. In this video, I am going to discuss the problem XOR Specialist that came in Codeforces round 752 Division 2. The problem statement starts with the following that you know who has an integer sequence a1, a2 up to an. Now he will split the sequence A into one or more consecutive subarrays so that each element of A belongs to exactly one subarray. And let k be the number of resulting subarrays, and h1, h2 up to hk be the lengths of the longest increasing subsequence of corresponding subarrays. Now, what is the longest increasing subsequence? The definition is given here. Let's say if a here let's take a look at the example. If 25335 is a sub is a sub is a subarray, then the longest increasing subsequence is 235 because here 3 is greater than 2, 5 is greater than 3. That is the condition here. See, if I2 is greater than 1 and I3 is greater than 2 and so on, then BI2 should be greater than BI1 and BI3 should be greater than BI2 and so on. So that is the thing. Like uh, here's if you see some other sub sequences, let's say 2 5, it is length 2, 2 3, it also has length 2, 3 5, it also has length 2, and only 2 3 5 has length 3, and it is a maximum one. And since we need the longest one, so the longest sequence here has length 3, and h1 h2 be the lengths of the longest increasing subsequence. So, for understanding it in a better way, there is an example here. The array is 2531432251. Now, if we divide it in three parts, let's say three subarrays, the first subarray is this, the second subarray is this, the third subarray is this. Now, in the first subarray, 25314, what is the longest increasing subsequence? It is 2, 3, 4, and it is length 3. If you take any other subsequence, that is in increasing order, you will see that it has either length less than 3 or any other thing. Means it is not greater than 3. The maximum value here is 3. Similarly, for this one, the longest length is 2. It will be either this 2, this 5, or this 2, this 5. We can take 2 to 5 because 2 is not greater than 2. Here, every next number should be greater than the previous number. And for subarrays of length 1, as there is only one element, the longest increasing sequence is also one, and so the h value is also one. This is very important. You should remember that when there is a sub area of length one, the h value is always one. Now, what is our aim here? uh, we have to say if it is possible to split the sequence A in such a way that the bitwise XOR of h1 h2 up to hk, that is all the h, is equal to 0 or not. We have to say whether it is possible or not. And you know, I guess you know what is a subarray. Subarray is that means if it can be obtained from an array by deleting several possibly zero or odd elements from the beginning or end, right? So let's take a look at the input. The input states that it starts with t, the number of test cases. It's then it will give the length of the array, that is n. Then it will give the array elements, n integers a1 a2 up to an, and also it is mentioned that sum of n overall test case doesn't exceed 3 into 10 to the power 5. Now what does this mean? This means that at max there will be 3 into 10 to the power 5 elements over all test cases. And we know in 1 second we can roughly do 10 to the power 8 operations. And as the time here is 1 second, so we have to follow one approach of either big of n or big of n log n, or else we will get time limit exceeded, that is TLE. And the output format is, if it is possible to divide the array into subarrays in the desired way, then the answer will be yes, that is will print yes, or else will print no. Now let's take a look at the example. Here, the example states the first example is like 1342215. This one. Now, here they have divided it in three parts 1342215. In the first subarray, the longest increasing subsequence is 3, has length 3, that's 134 because 3 is greater than 1, 4 is greater than 3. In the next subarray, the longest increasing sequence has length 1 because either we'll take these two or we'll take these two. We can't take both together because 2 is not greater than 2. In the third one, we'll take the whole subarray, so it is length 2. So the h values are 3, 1, 2, and the bitwise XOR of 3, 1, 2 is 0. We can write 3 in binary form as 1, 1, 1 as 0, 1, 2 as 1, 0. And if I take the bitwise XOR of all of them, it will give me 0, 0. So in case you don't know like how to find the bitwise XOR, then just remember the simple thing here that if there are elements like A XOR A, then it will be 0. And if it is A XOR A XOR A, then it will be A. And similarly, if it is A XOR A XOR A XOR A XOR, means 4 times, then it will be again 0. So from that we can conclude that if there are even number of same thing, then it will be 0. And if there are odd number of same thing that are XOR together, then it will be that thing. So with keeping this in mind, we'll go to the solution approach. Now, if you think in the same way as shown in the example, that is, divide the array into random lengths. Here, say the array is divided into lengths of 3, 2, 2. So let's say I have an array here of length n. It can be of any length. Let's say it is f length n. So I'll first divide it in this way, then this way, then this way, then this way, then again this way. So the length the length of the first subarray is 1, 2, 3, 4, 5, 6, 6. The next subarray has length 3. The next one has length 4. The next one has length 1. The next one has length 2. Now, these are the length of subarrays. Now, I have to find the longest increasing subsequence here. So, let's take some random values here. Let's say here the age value is 4. Here the age value is 1. Here the age value is 3. Here the age value is 1. Because we all know for length, subarrays of length 1, age value is always 1. And here the age value is 2. Now, if I XOR them together, 4 XOR 1 XOR 3 XOR 1 XOR 2, it gives me no guarantee that it will be 0. Means we have to actually calculate that. We have to find 4 XOR 1 XOR 3 XOR 1 XOR 2. Then only I can say that whether it is 0 or not. Without calculating this, I can't say beforehand whether it will be 0 or not. So if I go by this way, that is the brute force way, then what can I do? I have to find all the possible combinations in which I can divide the array into subarrays. Like the first combination can be that I will divide the array in parts of 5, 3, 4, sorry, 6, 3, 4, 1, 2. The next combination can be 4, 5, 4, 1, 2. The next combination can be 2, 3, then 8, 1, 2, anything like that. I can divide the array in many ways. And then for each of them, I will find the h value and then I have to calculate the XOR value. So calculating this will take a lot of time and it will obviously exceed the time limit. So also it works on some like random ways, and generally these problems doesn't depend on the random things. There is some better way or some means the better way is that it is a way in which I can guaranteedly say what will be the h value or what will be the x value. I can guaranteedly say I don't have to calculate that. So there is a better way, and we have to think how can we find that better way instead of taking this random lengths. So what can we do? Now, if you think carefully, then you will notice that if I divide the array into subarrays of length 1, that is if there are 16 elements in the array. Here the array is this, and let's say n is equal to 16. And if I divide it into 16 subarrays of length 1, that is all the subarrays will have length 1. So the h value will be 1, of course. H value will be 1 because for subarrays of length 1, h value is 1. And we know that means for that h value, then I can easily calculate the XOR value. XOR value will be like that 1 XOR 1 XOR 1 XOR 1 dot, 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 16 times. And I can easily calculate this value because we know that for even number of times it is 0, for odd number of times it is 1, right? That way, like if I divide the array into subarrays of length 1, we can easily calculate what will be the XOR value. So we'll follow this approach. So for this, we'll have some cases. So the case one when n is odd, n is even. That is the length of array is even. That means we can divide the array into even number of subarrays, right? If say the value of n is 8, that means there are 8 elements, then we can divide it into 8 subarrays of length 1, and the age value for each of them will be 1. So 1 will be XORed even number of times, and we know if something is XORed even number of times, the result will always be 0, right? And so our answer will be yes. I hope you can get that. Let's say I have an array 3, 5, 10, 15. So for this, I will divide it into four parts of length one. Here, the age values are 1, 1, 1, 1. And we know if I XOR one even number of times, the answer will be 0. And so we'll print yes. So our first case is open. Now let's go to the case when n is odd. Case 2, when n is odd. So for this, let's take a kind of an array. Uh, let's say this is the array. It has 5 elements. 1, 2, 3, 4, 5 elements. Now, how if I take subarrays of length 1, subarrays of length 1, this is one subarray, this is one subarray, this is one subarray, and so on. So the age values will be 1, 1, 1, 1, 1. And we know there are odd number of ones, and as there are odd number of ones, so the XOR value will be 1. But our aim is to make the XOR value as 0. So we have to think something better. Now, how can we think of something better? For this, I will quickly fill up the values so that we can think it in a better way. Let's say the values are 4, 8, 16, 10, 35, right? Now, what can we do here? What can we do here? Now, normally, while I was making subarrays of length 1, the XOR value was coming as 1 because there are odd number of ones. So, one thing that comes in our mind is that we can make a pair. We can make two numbers together as means one subarray of length 2 such that the age value still remains as 1. Age value still remains as 1, but the subarray becomes of length 2. So the number of 1 will reduce by 1, and so it becomes from odd to it becomes even. Let's say if I just take don't consider the numbers. If I just make this together, make this to a pair, then let's say the age value is also 1, and for others we know the age value is 1. So from odd number of ones, it becomes even number of ones, right? So that way we can make the XOR value as 0. So now when can we make the pair? That is the thing. When can we make the pair? Such that the age value still remains as 1. So for a pair, if you think carefully, like if there are two numbers, let's say A comma A and B. Now this subarray has length 2. When will the age value become 1, and when will the age value will become 2? So when A is less than B, age value will be 2, right? Because this forms an increasing sequence. But when A, B are such that A is greater than B, right? So A can be greater or equal to B because here the condition is it should be means the next element should be greater. So if it is equal also, then also we can get the age value as 1. Let's say here A and B are 5 and 3. So here the longest increasing sequence is always 1, right? So we have to find a pair such that the previous value is either greater or equal to the next value, right? And if I see in this array, here you see in the first pair 8 is greater than 4, so it's not possible, or 4 is less than 8, it's not possible. Then 8 is less than 16, it's not possible, but 16 is greater than 10. So yes, I can make this two number one pair as the age value will become 1, and for others the age values are already 1, right? And so the XOR value becomes 0, and our answer will be so the answer will be yes. So what we have to check here, we have to check that if we can find a pair such that AI minus 1 is greater than or equal to AI, if this is the condition in the in case of odd length arrays, then our answer will be yes. And if it is not the condition, that is, we couldn't find any pair that has length that has the previous element greater or equal to the next element. That is, all the elements are smaller than the next element. Let's take a look at an example. Let's say the array is 2, then 6, then 15, then 35, then 100. So here all the numbers are greater. No, means all the previous number are smaller than the next number. No previous number is greater or equal to the next number. So in this case, what can we do? We can make a pair just like we did in the previous case. What can we do? Let's think. Now, if I take here a subarrays of length 1, let's say I've taken a subarray of length 1 here. So the B2S representation of 1 is 1. So to make this 0, to make the XOR value 0, I have to take another subarray of length 1, right? Or any odd number would also, we can also have. It's not guaranteed, but another odd number can also help because odd number always has 1 in the last bit. Any odd number has 1 in the last bit. So I have to take either a subarray of length 1 or any odd length subarray. Then only I can means neutralize the first subarray, neutralize the value for the first subarray. So I will have to take either a subarray of length 1 or 3 or anything like that. Here I have taken 1. So for the first one, I have to take another subarray of length 1. Then only I can utilize that. And see, again, we are stuck with the same thing. We have another subarray of length 3, right? In case we have taken like here subarray, sorry, just a minute. So in case if we had taken something like here 1 and another subarray of length 3, then also like this one could have been neutralized to 0. Though this one remains, we will think of that later. But still, again, we have the same problem. We have the remaining array of odd length, right? We have this length is 1. So we means we couldn't neutralize the whole thing. At least one odd length array still remains. Now, if I take the sorry, now if I take even length subarrays here, let's say I have taken even length subarrays here. So even numbers always have 0 in the last bit, right? Always have 0 in the last bit. So so that the XOR value doesn't become 1, I have to take another subarray of length even only. Because if I take another subarray of length odd, it will have 1 in the last bit, and this can be anything. It will have 1 in the last bit, and the XOR value will become 1, right? So I have to take another subarray of length even only so that the XOR value remains the same. Here it should be 0 because even as 0 in the last bit. So the XOR value still remains 0. So I have to take another survey of length even only. And still, if we take two even together, just like we took two or together in the previous case, we'll still have this array, remaining array of odd length. That means here only there are two things. That is, if I take a subarray of length odd, I have to take another subarray of length odd so that the last bit, that is 1 in case of odd numbers, can be neutralized. And if I take two odd together, then we will have the remaining array of length odd. So the same problem will stay. Now, if I take a subarray of length even, then also we have to take another subarray of length even. So the exact value remains as 0. And if I take two even numbers, sorry, two even lengths together, then also the remaining subarray will be of odd length. And so the problems will still remain. That is, at the end also, we'll still get one subarray of length even, of length odd. It can be of length 1, of length anything. Generally, it will be 1 because if the array of length 3 is remaining, then we can take another yes, two subarrays of length 1 and 1, and at the end we'll have a subarray of length 1 remaining. That is the last element remaining, for which, like, yeah, if I take for that 1, then that subarray of length 1, then the XOR value will always be 1 in the last bit. The XOR value will always be 1 in the last bit because there will be one element remaining at last, and the subarrays of length 1 has h value as 1, and when I XOR 1 with 0, it will be again 1, and like that. So we can never make divide the array in possible subarrays such that the XOR value is 0. So the answer will be no here. That are all the cases here. So we'll quickly go to the coding part. Uh, Here, initially I have taken the test cases. Sorry. Initially I've taken the test cases. Then I have taken the length of array as input, and then I have declared the array. And then I have declared another Boolean variable that is flag as false. Why? Because we'll check whether there is a pair such that the previous element is greater than or equal to the next element. Whether the previous element is greater than or equal to the next element, then we will make this flag as true. Because if I can find such a pair in case of odd length subarrays, then our answer is yes. That is what we see. If the length of array is even, then of course our answer is even. Sorry, our answer is yes. And if the length of array is odd, but we can find a pair such that the previous value is greater than or equal to the next value, then also our answer is yes. Or else, in the last case, the answer is no. And this solution is also accepted. So I hope you could understood the solution. In case of any doubts, you can post it in the comment section. That's for that's all for now. Thank you.